All right, so now we are doing Atomic Theory 2, Part 1, Ions and Atomic Mass. So we just looked at isotopes, where protons and electrons were the same. We were figuring out neutrons, how they were a little bit different. Now we're going to look into ions. Ions. So the difference between ions and a regular atom is that atoms are usually implied to be negative, like a neutral, not negative, but like neutral, zero. There's no more positives than negatives. It's just zero. That means the same number of protons, the same number of electrons. Well, ions, they have a difference in electrons. And so they're charged. And it either means there are more electrons or less electrons. Electrons being the ones that are on the outside of the atom, more free to openly leave or gain from another element or particle. So if an atom gains an electron, it becomes negative. I know that kind of seems like in reverse, but we'll get to why that is so. And think of it this way. It's an anion with an N, an extra N, negative N, negative, anion. And then if it loses an electron, it is positive or a cation. Cats make me happy, so positive, or it's got the T, which looks like a plus sign, positive. So if it gains, it's the opposite, so it's anion. If it loses, it's the opposite, it's a positive, it's cation. All right, why is that? Well, let's look at this, lithium-7. So the net charge right here, it shows that it's a positive 1, which means that it lost an electron. How so? Well, looking at this, there's 3 protons, right? Let's get the neutrons. 7 minus 3, there's 4 neutrons. How many electrons? Well, if it lost an electron, that means there's 3, it went from 3 electrons to 2 electrons, right? So let's add this up. So a positive 3 plus negative 2 gives you a positive 1. That means there's less electrons than originally, so it's more positive, which is why it's a cation. Let's look at this exercise real quick. So we have this this ion X, and it is X31. Let's figure out what it is. Well, that 15 tells you what it is, and I'm looking at that 15, and I go over here, and I've got a P for potassium or phosphorus. Sorry, not potassium. Phosphorus 31, which means my mass number is going to be that 31. My atomic number, however, is right there. It's a 15. How many protons does that mean? Well, 15 is the atomic number, which means it has to be my protons. Neutrons, 31 minus 15, 16. Electrons, okay, so it's got a negative 3. Means it has 3 more negatives than it does positive. So I'm just going to say, I'm not going to say, I'm going to add 3 on to 15, giving me 18 electrons. It is more negative. There are 3 more negatives than there are positives. And in the nucleus, how many nucleons are there? There should be 31. What is my nuclear charge? It is 15. Remember, the nuclear charge doesn't change. It stays the same. It is the net charge that we're looking at. That net charge is negative 3. Okay? All right, and I think that is it for right now. Nope. Got one more thing to talk about, oxidation states. Okay, so how we know they're ions is by their oxidation states. Numbers in the right-hand corner of your reference table, page 9, up here, they represent the numbers of electrons an element will tend to either lose, which is positive, or gain, which is negative. It means there's more positives or more negatives, more electrons or more protons. Charges indicate common ions formed by each element. So aluminum usually forms a +3 ion, meaning it loses 3 ions. It loses 3 electrons, not ions. The atom has 13 electrons. Its ion has 10, because remember, it tends to lose those 3 electrons. So let's look at this. How many electrons does a typical zinc ion have? Now looking at zinc, Zn right here, it is a 30. So normal ones have 30, or sorry, 28. Maybe I looked at the wrong thing. It's probably got a +2. Okay. So does the element with 19 proteins tend to lose or gain electrons? Let's go back to the other one real quick. Zinc. So in your reference table, page 9, yes, 9, zinc right here, the Zn right there. It says it's +2, which means it tends to lose 2. And even though the proton is 30, which is what I automatically said, 30. Oh, no. It tends to lose 2, so its typical is 28. Let's look at element 19. Element 19. I got it. Does it tend to gain or lose? Remember, it's the opposite of the charge in the corner. So it's going to lose. And how many? See, 19 is right there. And in the corner, it tends to lose because it's the opposite, and it tends to lose 1. All right. So we will go over a couple extra worksheets to help us get into the ion aspect as opposed to the isotope. If you have any questions, please let me know, and I hope you guys have a great day.